Okay.
You can wait 20 seconds.
Of course.
I can pay you a glass of wine, but you know that best wine is in Spain, especially in Catalonia.
I know Italian.
Which is from investigate who will explain as the Tryton index
Overall.
So just give him current moment. Nicolas, whenever you want.
Okay.
Go.
Okay. So, oui. So I'll talk about the. Wow. Ça va? Ça va? Is it okay? Yeah, so I'll talk about the Tryton indexes and how we made them and why we changed the way we used to do. So I guess, what? Something is... Oui, je sais bien, but I cannot change the slide if I'm away from the...
Put the volume down. You're loud enough.
Yeah, okay. Which one is the volume? Non, celui-là, c'est... Ah, si. Ok. Attends.
Tu l'écartes un peu, en fait, le micro de toi. C'est parce qu'il est contre ton... Voilà.
Ah, ok.
On va essayer.
No, but I will thank you, Adria. Adrian, Adria, I never know. And I will keep saying Adrian. Yes, thank you. Oh, la technologie. Wow. Yeah, of course not. I guess a lot of people know what is SQL, but I will remind you of some stuff. SQL is an abstraction where you define basically what you want to do. And the rest is left to the implementation. So for example, you say, okay, select the ID from the sales where the sales date, the year of the sales date is 2023. And with this kind of query, you have a query plan that will make a parallel sequence scan. So this means that you will go on each row, call the function, and check if you match the condition. And this, when you test, piece of cake, it works. You have 10 invoices. There's not invoice, but sales. It works very fast. But when you work with 10,000 or 10 millions or hundreds of millions of sales, you will have a real problem. So, of course, people have thought about that and they created indexes which allow, in fact, to make fast searches. This is what people usually know about indexes. It makes faster search. But it makes some other queries efficient when you make a join or stuff like that. The indexes can be used, and so we need to make those efficient too. And also, indexes can help to reduce, to be faster, because you will reduce the input-output with the disks, and so gain some time there. There are basically different types of indexes. It's all based on computer science stuff, but you have the most basic indexes, which is based on the bay tree, which probably a lot of people know already, split the space of the data in the shape of a tree, where every piece of data is put in different stuff, and the tree is balanced in the way that you can reach a node quickly when you know where you want to go. For example, here, if you want all the data that are less than 7, it's this part of the tree that will interest you. If you want the data between 7 and 16, you will have the part in the middle, and so on and so on. And you can repeat that recursively. Then another big indexes, at least in Postgres, it's the hash indexes. This is like the dictionaries in Python. You have a key, and through some, I will say magic, but it's not magic. You can go from this data to the bucket where the data is stored. And then we have some specialized indexes, which are used, in fact, for spatial data, and also when you make data on text, and so on. So what was the previous situation? Before, the way to create indexes, there was two ways. You could put select equals true in a field, and the index was created for you. You don't have to do anything. It's nice. Or you could use the table handler's index action in the register. This was used to add and remove indexes. And it was nice because you could use, with the index action, a where clause to say that, okay, I will make an index, but only when the data match this kind of condition. And those two ways to create indexes, they were launched on the dunder register code. It seems like logical because that's where in Tryton, we do a lot of low-level stuff on the database. But the issue is that the dunder register call is made on each module, each time a model is used in a module. So you can see that it will make an issue later. And this created you an index that's displayed here. For example, it was an index that is not too bad on the account for the account deferral. Yeah, so this issue. The first issue is that we make the default kind of index. So it's always B-trees. You will never have an hash indexes with that, and they are not suitable for all the variety of situations we can encounter when we are working. So, for example, when we are making an equality between a data and a value, it's better to use an hash. Also, for the For the text data, it's better to use trigram indexes and so on. So also, one of the issues with that is that we went to a talk years and years ago by Marcus Winant, which is a guy from Austria, and he's quite known because he works a lot with Postgres, and he has pretty convincing talks about how index should be used, and the main point of the talk is that, in fact, the indexing is a development task. So this is the part there. And so indexes should be tied to the way the code use the data, not to the way you think it will happen or so on. So putting select equals true was, in fact, too simple because the code makes a lot of different stuff. So I explained that because the dunder call happened for each class registered in the module, you will call it multiple times. And so one of the consequences of that is that removing an index by adding a new module was not actually possible. And since we had, because we thought at that time that it was a good idea, we had put a lot of select equals true everywhere. We had a lot of indexes, but each time you put data that insert into a column with an index, you will make a constraint on the database, and it will do something and possibly do a lot of stuff. And so your query might be getting slower. And there was no way to fix that unless you go directly into the database and drop the index by yourself. But then, every time you make an update, the index are back in, and you have to make the query again, and it was a real pain in the ass. Yeah. So, we need to go to a better design, and I will explain now how a feature that is quite complicated can enter into Tryton, and it's not always easy. So the first idea, that was mine. Okay, remove everything. Usually I am a big proponent of removing everything because the less code, the less bug. So I tend to remove modules. I remove indexes. I remove almost everything that you can remove. Yeah, it was not a good idea. Because, of course, people will need indexes, and there are indexes that we know that we can use, so we decided to make something else. And also, this idea of removing everything and letting the DBA choose what indexes to do is contradictory with the fact that the code decides what index to do. So the way the second step was to decide to create a new kind of object that would be defined in the setup part. Why in the setup and not in the register? It's because the setup happens before, and when the register is called, it's only at this time that the stuff happens. So you can decide to remove it. And this object, the idea was to mimic the table handler's behavior. So in fact, in each implementation of the backend, so for the SQLite and the Postgres backend, because we have two, we had specialized index objects that would talk the way the database understands to create the indexes. And so we made this kind of interface where we put the name of the index, the table, the expression that we will use Is it an index, a specific, a unique index? And then a lot of quarks. the name for the index. My personal opinion is that it's good. But it's not. It's not the case anymore. And the link to the backend should be removed. That it's okay, everybody agreed about that. But yeah, we discussed a lot about it anyway, but yeah. So the next step was to remove the name of the index. And so now the indexes are created with name that looks like that. So if you go in the database, you will have indexes that are named something like that. Okay, it's created with the hash of the index request object. Why not? It has something that is positive. It's that you cannot have discrepancies between what is defined in the code and what is defined in the database. But because what could happen is that someone used the same name, drop the index, and create another name, another index with the same name, but with a different definition. So what to do in this case? Which one is the right one? By using an index that is computed based on the hash of the index request, we don't have this problem. And after all, SAP is using German names in the table definition, the tables, and we don't speak German, but we are used to see German names in the table columns. So people can use something that is not really understandable, but yeah. And since we decided to remove the index definition from the backend, we moved them into Model SQL, which is the right place to put it. So, what is the current situation? So, we have defined 3 index usage. The one that is called equality, which is the one that you will probably use the most. It's when you make equality comparison, maybe. In PostgreSQL, which is the one that interests the most people usually, it's the hash translator that puts a score to this. And so you defined it like that. So the SQL indexes is now a set, and you update the set to add a new index. Index request has been renamed to index. And you make an equality on the party name. This will allow you to query this table, the table T, really, really fast. Then you have the second index usage, which is also one that you will use a lot. It's the range usage. It's when you are using comparison operators, so less than, bigger than, and so on. In this case, we will use Bay trees, so you remember the computer science stuff. And the way to do that is, for example, here it's on the start date, you can put a range index. And one thing that is interesting is that you can specify that you want it to be order it. So you will order it in the decreasing sense. So it means that the data will start with the bigger one and until the smaller one, which will make the query that you will do on start date, order it by desk, to be really, really fast, because the data are already in the index in this order. And of course, you can make the same thing on the end date. And then we have the similarity index usage. This is used when we do queries on text, which use the % operators. In this case, there are two cases. In fact, in PostgreSQL, if you activated the trigram extension, which is an extension which allows you to make queries for similar strings fast, we will use this index, and it will use trigrams indexes. Otherwise, it will use a B-tree when we match on the % at the end. And to define it, you will see in Tryton a lot of time this kind of definition. On the table that defines the object, the reference usually will use a similarity. And so, according to the way you have defined, you have activated your database, you will have either a B-tree or the most efficient trigram extension index. So, some examples, because I know that it's easier with examples. For example, we have, I think this is in the invoices, an equality index on the state of the invoice. And we use it only when the state is in draft, quotation, confirmed, and processing. Why is there this index in Tryton? In fact, we use it to speed up the counting. When you open the invoices, you have multiple tabs, and you have the number of invoice in each tab, except for the invoice everything. And so, to do that, with this index, we speed up, because there will be few, hopefully, few invoices in those states, so we create an index for those, and we are able to count them very quickly, and indeed, it's used for the act window domains object. Then we speed up also search calls. For example, this is an index using an equality and also a range on the date. And you can see here that it's almost the same the same code, because we have an equal test on the journal, which is specified by an equality. And then on the date, we have an ordering by the descending order on the date, and we use the range with the descending order, which makes, in fact, this query, no, this one, much more faster. And then we can speed up also table queries. So, for example, when Sergi made his talk, he talked about table queries that can be used to make some simple statistics. And for this, we define the table queries which has special columns and so on. And we need to make them fast. So we define the index, and you can see that we can make an index also on a function of the table, because we are using here the function extract, which is a SQL function, on the date, and it's exactly the same as this one. Also on the month, it's exactly the same, and it's used in the join, so it will make the query fast. Okay? And then it's on the employee because it's used in the group by. So now we have a very flexible way of creating indexes that follow the way we define the queries, we define the data, and the way we use the data. It's not over yet. We have decided to add automatic indexes. So Tryton will sometimes help you and to create indexes automatically. For example, for every rec name field, if it's a scalar field, it will use the similarity index on it. So basically, if it's not a function field. On the equality of the document ID of the, we have an equality index on the document ID of every history table. So each time you define an history table, you have a link to the ID of the document. And we have an equality on this one automatically. There's also a range or equality similarity on the target columns used by the one-to-many and many-to-manys. So you know that when you make a one-to-many, there is a many-to-one field on the other end. And in this case, we use an equality index because we want those to be fast. So for example, you will have an equality index on the cell in the cell line ID, cell line table, sorry. And a similarity because you can also make one-to-many using a reference field. So the conclusion. The first one is that you have to use indexes. Sorry. They are important for performance. The second one is that the previous design we had was naive, to say the least, and suboptimal, but not too bad in the end, because a lot of indexes will end up being B-trees, so yeah. There were a lot of discussions during the development process. Really a lot. If you go back to the review, you will see it's spent on 3 pages or something like that. But in the end, we have a design that is way better than the first one, which I would like to remind you was this. So yeah, discussing is hard, painful, sometimes boring, but in the end, it's a bit better. No, it's way better. And also, I know the design is complicated, but it's at the expense of having a lot of flexibility. Maybe even a bit too much because we can do so many things. But I don't know, I'm not sure yet about that. And by default now we have way better indexes and they are tailored to the query we use and so on. So it's really good. And also it was one of the main points. If you want to get rid of an index, you can do so. That's the funny side. The funny thing is that it's this point that created all the others. Let's say, yeah, that's how it works. So, any questions?
Do you have some performance examples?
No. I know. In fact, that's one of the things I would like to do during the sprint. People might not know it, but there is a discussion about removing the search on the untaxed and tax amount on invoices. You don't remember it?
I remember.
Yes. And something like 4 months ago, I made a request to have people create a lot of invoices so that we can gather information about the indexes. And I had a proposal to not remove it, but use a query that is way more complicated than the one we have now, but that would use the indexes. And nobody did it. And I decided to do that during the sprint because obviously it will be used by anybody. So that's what I will do. And so by the end of tomorrow, I guess I will have an example. At least one.
Thanks. So this is in Tryton 6.8 now?
Yes, it's already in 6.6, I think.
Okay. And the existing indexes are not touched, right?
No, we don't touch the existing index.
Okay,
No.
thank you.
You can rest. We don't delete your indexes that already exist. Yeah, no, it would be stupid.
Just wondering how to remove an index, and is it allowed to remove any index?
All the indexes?
No, any, even the auto-generated index. It's not a good solution, but maybe a stupid question.
No, it's not stupid. Because I asked myself, how can you remove an index? So, in fact, the indexes are created into the underscore SQL indexes set. So, if you want to remove it, you have to use the same definition as the index. And on the SQL indexes, call removed. And if you want to remove one of the automatically created index, you have to do the same. So you have to create an equality index on the one that you want to remove. For example, the one on the target columns. But those index, if you want to remove it, it's because they are small, so I don't think you will want to do that. But indeed, to remove them, you have to create this index and call remove on it. Yeah. With the name on the other side, this one, if the index were named, you could just call remove on the name, pop the name. But yeah, I know. It's one of the many discussions we had. Ça te fait rire, toi. Okay.
One question here.
Yes?
Do you have an idea and a future plan to be able to remove unique constraints, which are like indexes?
No.
Okay, so we will continue using tricky hacks.
Yes. No, yeah, if a unique constraint is there, no, it should be for a good reason.
Since you are using hashes for the index as name, is there a thought about it to make a table index XYZ is like used for table number this and for following solutions, or to find them quicker?
To use hashes to create another table to make them.
You use a hash for each index.
Not for each index, in fact. It's only for equality indexes. So this kind of index, we use a hash.
Now, when you go back to the SAP thing,
yes, this one.
So you have an index name. I thought it's hash, but it's some name. But
yeah.
It's not really understandable for
I know,
everyone.
yeah, I know. It's not understandable.
Is there a thought about a kind of description for it?
Yes, we thought about creating a description on the index, and we haven't yet done it. But that's something that we have thought about already, yeah. So it will make, indeed, in the end, people that will browse the database, on Postgres you can put comment And we didn't think to put comment. And, but that's something that we have thought recently that should be done, indeed. So yes.
So no more questions? Okay, so an applause, please.
Merci.